Hello everyone, I welcome you all to Physics Wala, and basically in this session we are going to start our first chapter of chemistry, and basically in this session we are going to discuss about a very interesting as well as a very important chapter of physical chemistry, which is some basic concepts of chemistry, or I can say the most important part, that is mole concepts. So basically in this chapter we are going to discuss about the entire portion related to mole concepts. So first of all, this session is for 11th class students who are preparing for 11th class, who are in 11th class, but those who want to revise this particular chapter, like all those students who want to actually revise the entire portion related to mole concept, basically all the concentration terms, all the actual important aspects of mole concepts, they can also watch this particular lecture. And I can say class 12th students who are preparing for any examination, as well as droppers who are preparing for examination and who want to revise this particular chapter, they can easily revise the entire concept of this particular chapter, which is very important chapter, that is mole concept, with the help of this lecture. Okay, so first of all, I hope I am audible to everyone. I hope I am visible to everyone. Let me introduce myself. My name is Arpit Bharadwaj and I am a chemistry faculty at Physics Wala. So basically this session comprises of each and every portion related to mole concept. So first of all, let me tell you what we are going to discuss basically in this particular session. So there are some key concepts which we are going to discuss. First part is the introduction part. Now introduction seems very simple, but basically in this introduction part we are going to discuss about the SI units, we are going to discuss about the subsidiary units, derived units, we are going to discuss about the accuracy, precision, all those things. Then we are going to discuss about the next portion, which is very relevant, that is scientific notations as well as significant figures. What are the rules to write a significant figures, and what are the mathematical operations which are correlated with the significant figures. Then we are going to move on to the next part, which is atomic as well as molecular mass, the basic understanding of this particular part, and last part, which is the most important portion, which is mole calculation, how you are going to calculate mole whenever you are dealing with question. So basically in this lecture we are going to discuss certain questions which are from NCERT itself, as well as we are going to discuss certain questions which are basically from your previous year examination. Okay, so let's start. If I talk about the first part, that is the introduction part. So basically if we talk about the chemistry part, let me just define the basic term, which is chemistry. So chemistry is basically the branch of science which deals with the basic physical as well as chemical property analysis of all the chemicals, I can simply say. So whenever we talk about the term chemistry, it comes to our mind like we are talking about chemicals, we are talking about all these species, acids, base, salts, etc. We are talking about different type of reactions, but the basic meaning of chemistry is actually very easy. It simply says that chemistry is basically the branch of science which deals with the physical and chemical properties of matter. So if you remember your 9th class, you know about the entire description of matter. Let me just quickly revise that particular part. If we are talking about the concept of matter, I can simply say that matter is anything which has mass, which is going to occupy a particular space and which can be felt by our senses. So we can say it has mass as well as it has a volume and can be felt by our senses. That is the basic idea of matter. Now if we classify this particular part, I can simply classify matter into two parts. First one is your physical classification, or I can say physical states, and next part is chemical composition. Next part is chemical composition. So by physical appearance, I can classify matter into three major categories, although there are five categories, but I am talking about three major categories. First one in that case is your solid, next one is your liquid, and last one is your gas. I hope this part is clear and you know about all these things. Basically in the entire portion of physical chemistry, in 11th class itself, we are going to discuss about the gaseous state mainly, some portion of liquid as well as some portion of basic idea about the solid state only. Okay, if I talk about the chemical composition with the help of this particular part, you can again divide the chemical composition in two parts. First one is your I can simply say pure substance. So this is the same classification from your 9th class, so nothing new in this particular case. Next part is your mixture, or I can say impure substance. If I further classify this pure substance, I can simply say in case of pure substance, we have again two classifications. First one is element, and next one is basically compound. Okay. Definitely we are going to discuss more elaborately about each and every part in detail, but that is a separate portion. In the last portion of this lecture, we are going to discuss entirely about each and every part. Okay. If I talk about mixtures, I can simply say in this case we have first part, which is homogeneous mixture, and next part is heterogeneous mixture. Okay. In the same way, if I talk about elements, I can further classify elements into three categories. We have metals, we have non-metals, and we have metalloids. Okay, the basic idea. In the same way, if I talk about compounds, I can say first one we have inorganic compounds, and the next part we have organic compounds. I hope the entire part is clear to everyone. Now let's talk about the physical state. We talk about the physical state in a very simple manner. If I am just looking at the matter, what is the actual state of that particular matter? It can be solid, it can be liquid, it can be gas. If I talk about the solids, they are actually rigid in nature. It means that their particles are very close to each other. The force of attraction is very strong. They are very less movable. Only you can see a vibration between the particles. You cannot change the shape of this solid. They have a specific mass. Definitely they have a specific volume. They have a specific shape. If I talk about liquids, they are actually fluid in nature. They have a tendency to flow. It means the particles are slightly away from each other. The distance between the particles is actually moderate, but not that high. In this case, you can see the force of attraction again is moderate between the particles. You can see it has a specific volume, but no shape. It can take the shape of a container in which it is actually present. In the same way, if I talk about the gaseous state, we can simply say gases are compressible in nature. It means by applying pressure, you can actually compress those gas particles. It means the distance between the particles is actually quite large. It means the force of attraction between the particles is actually very less, and they have no specific volume as well as no shape. I hope the entire part about the physical state is clear to everyone. This is the basic idea which you guys already know. Now coming back to the next part, that is the chemical composition. In that case, I am talking about the actual behavior, actual type of particles which are present inside a particular matter. So I can say in that case, we have a substance which is pure in nature. It means it has only one type of particle. It can be anything, one type of atom, one type of molecule, but it has a one type of species present, which is the basic idea about pure substances. Mixture means we have more than one type of species. They can be atom, they can be molecule, it depends. Okay. So if I talk about the mixtures, if all the components are mixed in such a way that you cannot see a boundary separation between those species, you can say we have a homogeneous mixture. For example, let's take a glass of water and try to add 1 tablespoon of sugar. After stirring, you cannot separate or you cannot differentiate between sugar as well as water because there is no boundary separation. That type of mixture is actually known as homogeneous mixture. In the same way, if I talk about the heterogeneous mixture, I can say if there is a boundary separation between the species, definitely that mixture is a heterogeneous mixture. Like try to mix sand with water, you can see after some time sand is going to settle down and you can easily see a boundary separation between water as well as sand. So that is the basic idea about the mixture. Now the elaborated concept of elements, compounds, inorganic, organic, metal, non-metal, metalloids, we will discuss further in this particular session. So basically every time when we talk about the first chapter of chemistry, always remember this first chapter is going to be very important. Basically this part is from physical chemistry, so physical chemistry itself is very important portion. Now if I talk about the basic analysis of chemistry, it always starts with the study of matter. So we know every type of matter which has mass, which has volume, which can be felt by our senses. That is a particular analysis of matter. Now if I talk about further analysis of this particular chapter, I suggest you, if you are very interested to know about the discovery of entire chemistry, we know like Indians have a quite rich history about chemistry. In Hindi, you know, it's basically Rasayan Shastra or Ras Vidya, like that. So I suggest you to read at least first 2 or 3 pages of your NCERT book, which actually talks about different type of metallurgical extractions or different type of processes related to furnace creation, related to dye type of stuff, all these things like chemistry related stuff, the discovery of medicines, discovery of nanoparticles even, which were used in bhasm and all these things. I suggest you to actually read out those 2 to 3 pages of NCERT. You will be amazed, like we have a quite rich history related to chemistry. So those who are not interested that much in chemistry, you have to read those first 2-3 pages. You will get the actual idea, like we have a quite rich history of chemistry. Okay, now let's start with the first part. So whenever we talk about these type of species, definitely we are talking about different type of quantities. So different type of quantities, like if I talk about the matter, in that case I need to understand like how can I talk about the basic analysis of matter. So in that case, whenever we talk about matter, we are talking about its measurements, because I need to understand whenever I am starting any experiment or if I am talking about any type of element, I need to understand like what is the actual measurement of that particular matter. So in that case, when we talk about the measurement, we can talk about the physical measurement, or we can talk about the chemical measurement. Now, if I talk about the basic analysis, you all know physical measurement is very easy to understand. Definitely, I am talking about its weight, I am talking about its volume, I am talking about its density, I am talking about its length, like that. So, all the physical quantities which can be measured, that is the physical measurement. In the same way, if I talk about the chemical measurement, in that case, I am talking about the reactions basically. Its reaction with acid, its reaction with base, its reaction with any other component. So that is the basic idea about these type of reactions. So you need to understand whenever we talk about the first part of chemistry, we need to know that we are talking about the analysis of these physical quantities. So let's start with the first part, like what is the actual idea, what is the actual idea about these physical type of measurement. So basically in the entire chemistry part, you are going to learn about the chemical measurement with the help of different type of reactions, but this first lecture actually comprises of the physical measurement part. So if I talk about the physical measurement part, I can simply say, first of all, we need to understand what is the actual meaning of measurement. So measurement of any type of physical quantity is very easy. So basically in that case, I am talking about any quantitative observation which is actually represented by a number followed by its unit is actually known as your measurement. So always remember, we are talking about the representation of a number followed by a unit in which it is actually measured is actually known as the measurement. So basically we are talking about the measurement of physical quantity, of any physical quantity. And in daily life, we actually use these type of things very often. So let's say I'm going to purchase sugar. So I must say to the shopkeeper, give me 1 kilogram of sugar. So 1 is the number and kilogram is the unit. So basically I'm talking about the measurement part. In the same way, if I want to purchase some oranges, I can say give me 2.5 kilograms of oranges. So 2.5 is a number followed by its unit. So definitely that is a number. So let's say I want to measure the length of this particular pen. I can simply say it is 8 inches, let's say. It means a number followed by its unit. In the same way, if I want to purchase some apples, let's say 2 kilogram apples, it means in that case there is a number followed by its unit. Okay, so that is the part of measurement. I hope this part is clear. Now there are different type of systems related to this measurement. There is some English system and there is some metric system. So we have to understand, we have to normalize this thing so that we can use any type of measurement when I'm present in any of the country. Let's say I'm going to France. There might be a chance that their measurement type system is different. When I'm measuring the same thing in India, there might be a chance that we have different type of system, we follow different type of system. For example, you know this thing very often, that when we talk about the weight, generally the weight in India is actually measured in grams or kilograms, but the same thing is not followed in US, in different type of US cities. You know, like we have a different type of system. They generally refer weight as pounds, so they never use kilograms or grams, they generally use pounds. So you can see like different type of countries have different type of systems. So to normalize this thing, there was one unit which was derived, that is the International System of Units, commonly known as SI units, so that we can use every type of unit in every type of country with the help of same accuracy. So to measure all the physical quantities, first of all I have to understand, is there any basic part, is there any fundamental property which can be measured? So basically yes, there are 7 type of fundamental quantities. Basically the meaning of fundamental quantity is very clear. Those quantities which are not derived from any other quantity, but with the help of these quantities most of the other quantities can be easily derived. Okay, so these are 7 fundamental quantities, you all know very well. So first of all we have length, then we have mass, then we have time, then we have electric current, then we have amount of substance, which is very relevant, very important from chemistry point of view. Then we have luminous intensity, then we have temperature. I know like this is a theoretical part, I already told you that we are talking about a physical chemistry chapter, and physical chemistry means lots of calculation. But first of all we have to strong our base so that we can understand the meaning. Like when we actually read about these things, like they make no sense. Why we are reading about measurement, why we are dealing with these quantities, like what's the reason? But if you look clearly, whenever in chemistry lab, whenever a person told you to weigh 2.5 grams of that particular chemical, first of all you have to understand the basic nature of chemical, then you have to weigh the exact amount that particular chemical. How can you be so sure that that particular amount is actually very accurate? Like the experiment whatever you are doing with that particular weight is going to be the accurate one. So for the entire analysis of chemistry, you have to understand the basic idea of a measurement, its accuracy, its precision, and how you can actually check or cross check that whatever measurements you are doing, they are giving you the exact result. Because with the false result you will not understand the basic idea of that experiment. You have to be sure, you have to make sure that the results which are coming out from that experiment are actually very accurate. Okay, so for all these things, for all those experiments, first of all we have to understand about the quantities which are associated with those experiments, about the measurement, their units, as well as the basic idea how can we talk about the accuracy as well as precision part. Okay, so these are the 7 fundamental quantities. Now the SI units in that case, for length it's meter, for mass it's kilogram, for time it's a second, for electric current it's ampere, for amount of substance it's mole, for luminous intensity it's candela, and for temperature it's actually Kelvin. I hope this particular part is clear. Now there might be a chance that we have different type of other quantities also. Those quantities are basically derived from the fundamental quantities. So we generally say those quantities are basically derived quantities, and derived quantities also have certain units which are actually known as derived units. Now let's say I have an experiment which talks about the measurement of length. Now there might be a chance that that particular length is very large. There might be a chance that particular length is very small. So in that case, I can use certain prefixes to explain about the nature of that particular measurement. It may be a large analysis, it may be a very small analysis. So in that case, we generally use certain subsidiary units to actually explain about the large as well as small quantities associated with that particular measurement. So subsidiary units are basically, I can say, they are prefix. They are generally prefix to explain the large as well as a small quantitative measurement. Okay. For example, if you can see, this particular part is also present in your NCERT. So I have taken that particular picture from NCERT itself, which simply says that we have certain prefixes which are associated with the fundamental units. For example, let's say I'm measuring the length of, let's say a ship, which is going to be very large. Okay, so let's say I'm measuring the length of a particular ship, spaceship, whatever you have taken, measuring the length of a train. Okay, let's say, so I'm taking the length of a particular train, or I can say length of the train track. Okay, which is going to be very large. So in that case, I can say the value, let's say the value comes out as 101.00000 meters, which is quite large, So I can convert this length into another type of a unit with the help of certain prefixes, because this number is actually very large. So to convert large quantities as well as small quantities, we generally use these type of subsidiary units, which are generally prefixes. Now what's the meaning in that case? First of all, I have to decide a base unit from which I can start. It can be your it can be your gram, it can be your meter, it can be your Kelvin, it can be anything, like it can be anything. So I can say I have to first start with the base unit, then I can move in the smallest dimension, and I can move in the highest dimension. Now if I talk about the first part, let's say I'm starting with the base unit. So 10 raised to the power minus 1, which is a smaller quantity, is denoted by the help of a prefix which is known as a deci. So let's say I'm talking about 1 decimeter. I'm talking about 1 decimeter. So the base unit is definitely meter. I can say decimeter is nothing but a 10 raised to the power minus 1 meter. Or I can say 1 meter will be equal to 10 decimeter. Okay, that is the basic idea about your unit conversions. So in that case, this is your base unit, which is your meter, and this particular part is actually represented with the help of a particular prefix, which shows that we are talking about the decimeter. Okay, so first part is deci. Then we have centi, which is 10 raised to the power minus 2. Then we have milli, 10 raised to the power minus 3. Then we have micro, 10 raised to the power minus 6. Nano, 10 raised to the power minus 9. Pico, 10 raised to the power minus 12. Femto, 10 raised to the power minus 15. So in chemistry, up to femto is actually fine, because in every type of dimensional analysis, we can move up to femto part. Okay, but after that we have atto, then zepto and yocto. The meaning is atto is 10 raised to the power minus 18. Then we have a zepto, which is 10 raised to the power minus 21. Then we have yocto, 10 raised to the power minus 24. Now moving to the large part, we can say we have a like deci, 10 raised to the power minus 1. We have 10 raised to the power 1, which is deca. Then we have a hecto, 10 raised to the power 2. Then we have a kilo, which is a very common term. Kilogram, which is 10 raised to the power 3 gram. So 10 raised to the power 3. Mega, 10 raised to the power 6. Giga, 10 raised to the power 9. Tera, 10 raised to the power 12. Then we have peta, which is 10 raised to the power 15. So up to that part, everything is Fine. Other than that, we have hexa, zepta and iota, 10 raised to the power 18, 21 and 24, just like these three quantities. So I hope this entire part is clear. So up to this part, it is very essential to know about these quantities because they are very often used in chemistry. Okay, I hope this entire part is clear to everyone. Okay, now so we have one question from NCERT itself. So question says match the following prefixes with their multiples. So the same type of conversion requires. First part is a micro, then we have deca, then mega, giga and femto. Okay, so let's try to decode this particular part. Okay, so first part is micro. Okay, micro, we already know in that case we are talking about 10 raised to the power minus 6 is micro. Okay, which is represented by mu in this case. So we know that we have meter, let's say, and I want to convert into micrometer. So I can say 1 meter is equal to 10 raised to the power 6 micrometer, or 1 micrometer is 10 raised to the power minus 6 meters. Okay, one simple conversion which you should know. Okay, now next part is we have deca. So just like deci, which is 10 raised to the power minus 1, deca is 10 raised to the power 1. So we have this deca also. Okay, next part we have mega, giga and femto. So femto is very clear that we are talking about 10 raised to the power minus 15. I hope this part is clear. Next part is giga, which we all know it is nothing but 10 raised to the power 9. And last part which remains is basically your mega, and you already know this mega is nothing but 10 raised to the power 6. I hope this part is clear to everyone. A very simple question from NCERT itself. Okay, now moving to the next part, we have certain derived quantities which are derived from the fundamental ones. So I have a list of certain quantities. There are also different type of quantities which are derived quantities, but in this case I have written only few. So if I talk about the first part, which is area, you know, in this case it is basically L into B. So if I talk about its unit, which is going to be meter square. If I talk about volume, definitely it's L into B into H, which is basically having the unit meter cube. Just like that, we have a density. Density is basically mass per unit volume. So mass is again a fundamental unit having the value kilogram. Volume is again a derived quantity, so which is having the unit meter cube. So kilogram per meter cube, or you can use gram per centimeter cube. Okay, so both these things are used. Either you can use kilogram per meter cube, or you can use gram per centimeter cube. Okay, just like that, we have a force. So F is nothing but mass into acceleration. So you know the unit of mass, which is kilogram. Acceleration is a meter per second square. So you can say it is a kilogram meter per second square, and generally this entire part is actually known as a Newton. So we have a specific unit for that particular part, which is known as a Newton. In the same case, we have a pressure, which is a force per unit area. So force, you already know, Newton. Area is a meter square, so Newton per meter square, which is also known as Pascal. So this particular part is Pascal. Okay, so these are few quantities which are actually derived quantities as well as their derived units. So we are going to learn about these type of units as well as these type of quantities in this particular chapter. Okay, now talking about the next part, we are talking about the dimensional analysis. Basically it is associated with the subsidiary unit parts, how you can convert one unit into another one. So this is basically for the unit conversion part, because in chemistry most of the students are very confused about the unit conversions. So let me tell you a very simple thing, how you can convert units, one unit into another one with the help of a very simple formulation. So you just have to remember three simple ideas, three simple steps. First part is determination of a unit conversion factor. This is the most important part. What is this UCF, unit conversion factor? So first of all, you have to determine what is the unit conversion factor. Then the second and third steps are very easy. What you have to do in the second step? Multiplication of the quantity with the UCF, unit conversion factor, and then in the multi-step conversions, cancel out the units of a preceding factor. That's it. That's it. So these two parts are very easy. The first part is unit conversion factor. So let's say I say that 1 meter is equal to let's say it's going to be 100 centimeter. Let's say. So in that case, I can say that 1 meter divided by 100 centimeter is equals to 1. Okay, first part. Or I can say from this particular part, I can also say that 100 centimeter divided by 1 meter is also 1. Okay. Now both these things are actually your unit conversion factors. Both the things are your unit conversion factors. Now let's say in the given quantity, I want to convert any given quantity which is in meters into centimeters. Then I can use this particular part. And if I want to convert centimeter into meter, then I can use this conversion factor. So you need to understand how you can write the unit conversion factors. I hope this part is clear. Now let's talk about a simple question, then we will understand better about the entire conceptualization. So let's talk about a simple question. Okay. So let's say we have a question. A vessel contains 2 liter water. The volume of water in meter cube is. So first of all, we have to understand what is the conversion between liter as well as meter cube, because the question is saying you have to convert liter into meter cube. This is the requirement of the question. So I can simply say with the help of values, which we are going to discuss again. Just let me tell you. So let's say we have a 1 meter cube which is equals to 10 raised to the power 3 decimeter cube, because 1 meter is equal to 10 decimeter. Okay. In the same way, if I talk about the next part, which is equals to 10 raised to the power 3 liter. Okay, this is the first part. So I can simply say that 1 decimeter cube is equal to 1 liter from this conversion. Next part, which is again equals to 10 raised to the power 6 centimeter cube, which is again equals to 10 raised to the power 6 ml. Okay. So from that particular part, I can say that 1 centimeter cube is equal to 1 ml. Okay, I hope these two conversions are clear to you. This is a very simple conversion part. You just have to remember this thing. Then entire part will be clear to you. Now you know that 1 meter cube is actually equals to 10 raised to the power 3 liters. So from that part, I can say that 1 meter cube is equal to 10 raised to the power 3 liter. So there are two unit conversion factors. First part is 1 meter cube upon 10 raised to the power 3 liter will be equal to 1. This is your unit conversion factor. And next part is 10 raised to the power 3 liter divided by 1 meter cube is again equals to 1. This is your unit conversion factor. Okay. Now I want to convert this 2 liter into meter cube. Can I use this particular part? Yes, definitely, because this liter is going to be cancelled out with this liter and we will left with only meter cube part. So I can say that we have the quantity which is 2 liters. I can multiply it with 1. Nothing new. 1 means I am talking about the unit conversion factor, and I can write it as 2 liters multiplied by 1 meter cube upon 10 raised to the power 3 liter. Now you can see liter here. You can cancel out this particular part and you will left with 2 multiplied by 10 raised to the power minus 3 meter cube. Because this 10 raised to the power 3 when comes to the upper side, it will become a negative term, and you can see we have 2 multiplied by 10 raised to the power minus 3 meter cube. That's the basic idea. So you can say we have the answer which is 2 multiplied by 10 raised to the power minus 3. I hope this entire part is clear and you know about the significance of unit conversion factor. Now there are certain questions in NCERT itself about the unit conversion part. You can practice those questions by yourself. Okay. Now coming back to the some conversion factors. we have the first part, which is mass conversions. So in case of mass, we have different type of units. If I talk about the SI unit, which is very clear, that is kilogram, but I told you in English system we generally use lbs, pounds, which are like this. So 1 kilogram is basically 2.2046 lbs. 1 lbs is basically 453.59 grams. But the most important part in terms of chemistry, sorry, in terms of chemistry, it is basically your term, which is AMU. So AMU is atomic mass unit, which has the value 1.66054002 multiplied by 10 raised to the power minus 24 gram. So definitely we are going to calculate this particular part also. I will let you know how to calculate the AMU part. Okay. Now the next part is basically your pressure. Pressure, I told you, force per unit area. Now in case of pressure, we have a different type of units. We can use ATM, atmospheric pressure, we can use bar, we can use torr, we can use mm of mercury, we can use Pascal. All the units are actually present. Now if I talk about the Pascal, Pascal is basically Newton per meter square. If I explain Newton, it is basically, I can further explain about the Newton. So first part is, if you know that pressure is basically force per unit area. Force is having unit which is Newton, and this particular part is meter square. So we have Newton per meter square. Now we know that a force is nothing but mass into acceleration, which is basically kilogram meter per second square. Okay. So you can put this particular value and you will left with the final value as Newton is kilogram. So we have a meter and it is basically cancel out by 1 meter square. It will be meter minus 1 and we have second minus 2. So you can say we have derived the same units, which is 1 kilogram per meter per second square. Okay. In the same way, if I talk about the next part, ATM, this is the most important unit which we are going to use in gaseous state chapter. So 1 ATM is basically 760 torr, or it is equals to 760 mm of mercury. Okay. In the same way, it is basically equals to 101325 Pascal, or I can say it is basically equals to 1.01325 bar. So from that particular part, you can correlate that 1 bar is equal to 10 raised to the power 5 Pascal. So these are some unit conversion parts which you should know. In the same way, if I talk about the next part, we have a specific factor for temperature, then unit, SI unit is basically Kelvin. Other than that, we have degree Celsius as well as degree Fahrenheit. So in that case, if I want to convert this entire part, I can use different type of formulations, but I generally prefer to use one very simple analysis, which is degree Celsius minus 0 will be equal to Kelvin minus 273 equals to degree Fahrenheit minus 32 divided by 180 divided by 100 and divided by 100. So you can use this particular conversion chart to convert each and every value, because there is a separate formula for degree Celsius to Kelvin conversion, and there is a separate formula for degree Celsius to degree Fahrenheit, but there is no direct formula for Kelvin to degree Fahrenheit. So this is the relation you can use. Just have to remember this particular formula, very simple one. Okay. Now in the same way, if I talk about energy, energy again have different type of units. It can be joule, it can be calorie, it can be like electron volt. It depends upon the type of quantity I am using. So generally the SI unit in that case is actually joule. Okay, so 1 joule is basically kilogram meter square per second square. Then we have a calorie, which is 4.184 joules. Okay, and electron volt, which is 1.6, that is the charge of electron, I must say, 1.602 multiplied by 10 raised to the power minus 19 joules. I hope this entire part is clear. Now talking about the next part, which is the accuracy and precision. Now to understand this particular part, let's try to summarize everything which we already discussed in this particular session. So we have started with the first part, that is the actual idea about matter, its classification. Then we started with the physical measurement part of a particular quantity. So basically in chemistry we are going to deal with different type of quantities. Definitely we are going to talk about chemicals, we are talking about the length, we are talking about the mass, we are talking about the density of that particular substance. So in that case we are talking about the apparatus which is going to be used for the application part. How you are going to measure? You cannot measure two chemicals, one stone is here and one stone is here, and you can say, oh, one weight is going to be 400 gram and next one is 400.5. It's not possible. You cannot measure that particular part like that. You need a particular apparatus. With the help of that you can actually measure the quantity, like the mass, you can measure the length, you can measure the density, you can measure the volume, you can measure the size, whatever it is. Okay, so for that particular part I need the apparatus which is going to be used for the application. So for volume analysis I need a specific apparatus, for mass analysis I need a particular apparatus. Now how can I be so sure that whatever mass I'm actually weighing, that mass is actually accurate, that mass is actually the true value? So for that particular apparatus, the two important things which are required is, first one precision and next one is accuracy. Now they are not required for apparatus only, they are also required for our own analysis. So let's say I'm actually doing an experiment. I'm doing an experiment which is titration, very common experiment. I just want to know the amount of unknown substance. So in titration I need to make sure whatever readings are coming, they are actually accurate. Let's say I'm measuring the pH. I need to make sure that whatever pH is coming is actually true. Let's say I'm measuring the weight. I need to make sure that whatever weight I'm measuring, it is the accurate weight. So for that particular part we need to understand two terms. First one is precision and next one is accuracy. Now what's the meaning in that case? So the meaning is very easy, but you cannot differentiate these two things. Let's say I want to ask you, like, what is the actual meaning of accuracy and precision? You will be like, sir, I guess both are same. Sir, accuracy is the accuracy of result, precision is the precision of the result. It means the values are actually close, it means we are getting same type of values. But the actual understanding of accuracy and precision is a very easy, trust me. So first of all, you have to understand, whenever we talk about the accuracy and precision, we have to understand we are talking about an experiment, because without an experiment you cannot talk about accuracy and precision. There is no meaning. So let's say I'm doing an experiment. I'm measuring the weight of a particular substance. I know, let's say I know the actual weight of that particular chemical. Let's say the actual weight of that chemical is 2 gram. Let's say the actual weight. So I can say this 2 gram is the true value. 2 gram is the true value of that particular measurement. Whatever measurement I am doing, 2 gram is the actual value, true value. Okay. So first term is a true value. Now let's say in the experiment, I am trying to weigh that particular chemical. First time when I am putting that particular chemical in the weighing scale, the weight actually comes out as 1.93 gram, let's say. Okay. Second time when I am measuring that particular chemical, the weight is actually coming out as 1.95 gram. So you can see, sir, there is an error, because you already told us the true value is 2 gram, but you are measuring the weight as 1.93 as well as 1.95 gram. So you can see there is a chance of error, and it can be human error by me. Let's say I'm weighing the chemical with wrong method, let's say. So it is the human error I'm doing. It may be a chance that machine is not calibrated, machine is not correct, it is again giving me the error. But both the time you can see 1.93 and 1.95, they both are closer to each other, but they are very far from the true value. Okay. So if I talk about the average of 1.93 as well as 1.95, it is approximately 1.94. So you can see these two measurements are closer to the average value. Second term is average value. They are closer to the average value, but they are very far from the true value. So I can say we are talking about the precision in the results. When the measurement values are closer to each other and closer to the average of the measurement value, they are actually precise in nature. That's what you can see. If the values of different measurements are close to each other and close to the average value, the measurement is said to be precise. I hope the first part is clear. Now let's say again I am doing the same experiment. Now this time the first measurement value comes out as 1.99 and second time it actually comes out as 2. So I can say that both the values are very close to the true value. It means the result is going to be very, very accurate. And that's the definition. If the average value of different measurements is close to the true value, the measurement is said to be accurate. I hope this part is clear. Very simple analysis. Now let's try to make it more interesting. So you all know about this magnetic dart, okay, and we have something which is used for the target part, okay. So let's say these are the magnets I am using, not the pointed one, but the magnets I am using to shoot on this particular target, okay. Now let's say in first time I am giving 3 chances to everyone, A, B, C and D. In first chance you can see in first chance this part goes to this side in first chance, second chance it goes to this side, and in third chance it goes to this side, okay. Now after observing all the 3 magnetic darts, you can see that they are very far from each other. It means their average value is going to be somewhat in between, and it is very far from the average value also. They are not closer to each other, first part, and they are not closer to the true value. It means the result is very easy. The result is very easy, that it has a low accuracy as well as a low precision, because all the values are far from each other, first part, and they are far from true value. It means they are neither accurate nor precise. Second time, so in second chance, first part comes out to this side, okay, in first attempt. In second attempt it was like this, and in third attempt it was like this. Now after seeing this particular part, you can say all the 3 measurements, they are close to each other. All the 3 measurements, they are close to each other, okay. But the thing is, they are far from true value. If they are close to each other, it means they are precise, but they are far from the true value, it means they have low accuracy. So I can say this result is showing low accuracy but high precision. Now the next part, the first attempt goes to this side, okay. The second attempt goes to, sorry, this is the first attempt, goes to this side. The second attempt goes to this side, let's say, and the third measurement, let's say the third measurement goes to this side, okay. Now you can see they are actually close to the true value. They are close to the true value, but they are far from each other, okay. You can see they are close to the true value. It means they have high accuracy, but their precision is going to be very, very low. They are low, they have low precision, okay. Now the last part, last experiment, which is the most important one. So we have the first measurement like this, the first dart goes to this side, okay. The next part goes to this side, the next part goes to this side. Now you can see the most important observation. They are close to each other and they are close to true value. It means this is the best result. You can see it has high accuracy as well as high precision. So let's say I am giving you a chance to select an apparatus. First apparatus is having low accuracy and low precision. Second apparatus is having low accuracy but high precision. Third apparatus is having high accuracy but low precision. And last apparatus is having high accuracy as well as high precision. You will definitely select this particular part. You will select the apparatus which is showing high accuracy as well as high precision, because every time you are doing the same measurement, you will get the same type of results, and that's how we can choose these things in chemistry. So that's the basic importance. Generally we forget about all these things because they doesn't matter to us at all, but yeah, they are very relevant. Without these things, without accuracy, precision, without the basic idea of units, there is no meaning to do an experiment, because I will be unaware of many factors. I will be unaware of the errors which are coming in the experiment. I will not make sure that my experiment is giving the actual result. Okay, so this is the basic idea about the accuracy and precision. Okay, now the next part which is associated with this particular portion is the representation in chemistry. So in chemistry, you know that we are dealing with the very large quantities. Definitely we are going to deal with very large quantities. Definitely we are going to discuss very small quantities. So every time whenever I am doing the calculation, it's not feasible for me to write down the entire number. So let's say I am talking about a number which is distance. I am talking about the distance which is 299,876,321,00. This is in, let's say, meters, and I am adding one more distance which is 99,873,212,00 meters. I am adding this particular part with this particular part, and there are multiple questions related to these long calculations. It's not very feasible to write down the entire number and to calculate, because there might be a chance that calculation is going to be irrelevant, the calculation is going to be wrong. So I need a representation to actually represent a very large quantity as well as very small quantity, and yeah, definitely in chemistry we have the solution. That solution is basically known as scientific notation. So a scientific or exponential notation is basically a way of writing very large and very small numbers, in which the number can be represented in the form of a multiplied by 10 raised to the power, which is basically a multiplied by 10 raised to the power n. Now n is basically the exponent having positive or negative value. So basically it is the exponent having positive and negative value, and a is basically vary between 1 and 10, or I can say the actual meaning of this a is basically 1.000 and so on to 9.999 and so on. Okay, so that is the basic idea about a as well as n. Now how to write the scientific notation? This is the most important question. How can we write the scientific notation? It's very easy. So I can use the scientific notation to explain a large number as well as a very small number. So these numbers are hypothetical. So first of all, for a very large number, what I have to do, I have to move the decimal from right to left. I need to move this decimal from right to left. Okay, now in a small number I have to move this decimal from left to right side. So I have to move this particular part from left to right. Now remember when we are talking about the movement of the decimal from right to left, the exponent n will be a positive term, and in this case the exponent will be a negative term, and it depends upon the places I am going to jump. So let's say I am talking about the jump from this point 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22 and 23. I am moving the decimal to 23 places. So it will be 6.02 multiplied by 10 raised to the power 23, which is a very convenient number in comparison to this particular part. Now the next part, I am moving the decimal from 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31 and 32. Okay, so that will be 9.1 multiplied by 10 raised to the power minus 32 kilogram. Now you can see like this measurement is a very easy. So this minus 32 represent a very small number and plus 23 represent a very large quantity. I hope this entire part is clear. Now there are certain mathematical operations which are associated with the scientific notations. How you can add those large numbers, how you can subtract those very small numbers, how you can multiply as well as divide these quantities. So the rules are very easy in that case. First of all, if I talk about the subtraction as well as addition, the most important thing is I need to make sure that this 10 raised to the power n is actually same. Then only I can apply this operation of addition as well as subtraction. So let's say I have 6.02 multiplied by 10 raised to the power 3 and I am adding 3.14 multiplied by 10 raised to the power 2. I cannot do this. I have to make sure that these components are having the same value. Okay, so this is 10 raised to the power 3. I have to convert this entire part into 10 raised to the power 3. It means I have to make sure that I'm taking this decimal to this place so that I can have positive exponent. So I can write it as 0.314 multiplied by 10 raised to the power 3. Now the exponents are same. We have 10 raised to the power 3 as well as 10 raised to the power 3. Now I can add these two numbers, which is 6.02 with 0.314. That will be 6.334 multiplied by 10 raised to the power 3. Now you can do the same question. I am giving you the same question as a homework. You can do the same question. We have 6.02 multiplied by 10 raised to the power 3 minus 3.14 multiplied by 10 raised to the power 3. Okay, just do it by yourself and let me know the answer in the comment box. Okay, very simple question, very simple analysis. Now the next part is multiplication and division. Now in this case, just make sure that this 10 raised to the power n, whatever the value of this 10 raised to the power n is, like there is no confusion, like there is no need to convert 10 raised to the power n in same terms. What you can do, in case of a multiplication, just add the exponent. Okay, in case of division, just subtract the exponent. That's it. Okay, this is the most simplest thing you can do. So for example, we have 3.1 multiplied by 10 raised to the power 4 multiplied by 2 multiplied by 10 raised to the power 3. So these are the simple numbers, 3.1 and 2. Just multiply these two numbers. Now in terms of this exponent, you just have to add these values because they are in multiplication. So we have to add the exponent. So first part is 10 raised to the power 4 plus 10 raised to the power 3, that will be 10 raised to the power 7. Okay, I can do the same question for division part. So we have 3.1 multiplied by 10 raised to the power 4 divided by 2 multiplied by 10 raised to the power 3. What I can do, I can solve it by 3.1 divided by 2 multiplied by 10 raised to the power 4 minus 3. So in division, these are going to be subtracted. So we will left with this is going to be 3 ones are, then we have 3 5s are, sorry, 2 ones are 2, 2 5s are 10, 1.55 multiplied by 10 raised to the power 1. That will be the final answer. Now somebody must be confused, like, sir, what happens if we have 3.1 multiplied by 10 raised to the power 4 multiplied by 2 multiplied by 10 raised to the power minus 3? What can we do now? Just add the powers. Okay, so we have 3.1 multiplied by 2, which is 6.2 multiplied by 10 raised to the power 4, then plus, and this is minus 3. Just simply add. So that will be 6.2 multiplied by 10 raised to the power 1 only. Now what happens if I am using the same equation? 3.1 multiplied by 10 raised to the power 4 divided by 2 multiplied by 10 raised to the power minus 3. So you just have to subtract the powers, same. So in this case you will have 1.55 multiplied by 10 raised to the power 4 minus, then minus 3. So this will be minus minus plus. So you will be having the value 1.55 multiplied by 10 raised to the power 7. That's it. Okay. So nothing fancy, a very simple operation in that case. Okay. Now, okay, so we have certain other questions from NCERT itself. Question says express the following in scientific notation. How you are going to explain this particular part? Very easy. So first, in first case, we have the value 0.0048. I can move this decimal from left to right. It means exponent is going to be negative. So that will be 4.8 multiplied by 10 raised to the power 1, 2, 3. That is minus 3. Okay. Now in this case we have 1, 2, 3, 4, 5. So 2.34 multiplied by 10 raised to the power 5, because I am moving the exponent from this to this side. 8008 is 8.008 multiplied by 10 raised to the power 3. Then we have 500.0, that will be 5.000 multiplied by 10 raised to the power 2. Then this is very easy, 6.0012, which is already in the part where it is explaining the value of A, multiplied by 10 raised to the power 0. Because there is no extra part, 10 raised to the power 0 means this value is basically 1. So the number multiplied by 1 is having the same value. So you can write it as 10 raised to the power 0. I hope the entire question is clear. Very simple question from NCERT itself. Okay. Now the next part is quite interesting, which is the basic idea of significant figures. Now most of the students are actually very confused when they are dealing with the significant figures, because they don't know how to deal with this particular concept, like what is the actual analysis of significant figures. So let's try to find out. First of all, we will select a very interesting color. Okay. Let me try again. Okay. So whenever we talk about any type of measurement, we are using an apparatus. How can I be so sure that the apparatus is giving me the accurate value? How can I choose 3 apparatus? So let's say I have the weighing machine. This is the first weighing machine, and in this case we have let's say I have the weighing machine. Okay. Let's say I have 2 weighing machine. Okay. I have 2 weighing machines. Okay. In first case we have okay. So in first machine, when I am weighing my weight, it is coming out as 72.5 kilogram, let's say. Although my weight is not 72.5, definitely it can be 82.5, but I am not sure. Okay, so first part is, let's say the first weighing machine is giving me the weight which is 72.5. Now the next machine is giving me the weight as 72.52 kilograms. Which machine is more appropriate according to you? Just let me know the answer in comment box. Which machine? So this is the machine number 1 and this is the machine number 2. Which machine are you going to prefer whenever you are measuring your weight? First machine or second machine? definitely your answer is going to be second machine. I am pretty sure, because you are going to say, sir, it is giving the value up to more decimal numbers. Let's say I have third machine. Let's say I have a third machine. And this is giving me the value as a 72.524 kilogram. Let's say this is the machine number 3. Now your answer is going to change. Sir, we are going to prefer machine number 3 because it is giving us the value up to 3 decimal point. But what's the meaning? Now compare these two values. These two measurements. In this measurement, you can see this digit, which is a 5, is actually uncertain. It can be 5, it can be 5.2, it can be 5.1, it can be 5.3, it can be 5.9. So you can see in this measurement, these two digits are going to remain as it is, but this is the uncertain digit. So whenever I am measuring the weight in this machine, I need to make sure that these two numbers are going to be certain. These are having a specific value, but this number is the fluctuating one. This is the uncertain one, because you can see the fluctuation in this particular part at the instant whenever you are just hopping on the weighing machine. So these two digits are certain. Now in this particular apparatus, you can see if I am comparing this with this particular part. So the digit which is showing uncertainty is this 2, because it can be 2.1, it can be 2.2, it can be 2.3, it can be 2.4. So you can see in this measurement, these 3 units, these 3 digits are actually certain, but this digit is actually uncertain. Now you can understand the basic idea about the measurement part. So every type of measurement is actually associated with certain fixed terms, fixed digits, as well as some uncertain digits. So that is the actual analysis of significant figures, because in every apparatus I need to make sure whatever values I am getting, they are actually very accurate, they are very precise, and the measurement whatever I am doing is going to be very, very true. So in that case, the significant figures are actually playing a very important role. I can simply say the total number of digits in a number, including at least one uncertain digit. So I can say all the certain digits plus at least one uncertain digit comprises of significant figures. And why I am talking about certain and uncertain digits, now you have a clear understanding. When you are comparing machine number 1 with machine number 2, you can see like this 5 is going to definitely give us different values when I am changing the decimal points of the precision, or so of the apparatus, sorry. It means this 5 can be 5.1, 5.2, 5.3, 5.4 up to 5.9, anything. So this is the fluctuating one or the uncertain one. All the digits 72 are certain. Now I am comparing these two apparatus. You can see this last digit, which is 2, is actually uncertain because it is giving us different values. And in every type of measurements, you can see the last part, which is the farthest from the decimal point, is the most fluctuating one. It gives very uncertain values. After some time, it is going to be calibrated and gives you the final result. So that is the basic idea of significant figures. I need to make sure that in the particular result, I am including all the figures which are relevant for the measurement part. So which comprises of all the certain digits as well as at least one uncertain digit. But the question is, how can we talk about this significant figures? How can I calculate the significant figures? So there are certain rules by which we can actually identify significant figures. First part is a very simple rule. All the non-zero digits are actually significant and all the zeros between two non-zeros are actually significant. So let's say in the measurement, I am getting the value which is 123. So I can say significant figures are 3 in this case, because all the values are non-zero. In the measurement, let's say the value is 1203. How many significant figures are there? Now this 0 is actually present between two non-zeros. So I can say this is significant. So we have total 4 significant figures. For example, I have the measurement value which is 12.354. So in this case, all the values are non-zero. I can say total significant figures are 5 in this case. And let's say the next part is 8008. So in this case, zeros are basically present between two non-zeros. I can say there are 4 significant figures. I hope the first rule is clear to everyone. Very simple rule, very elegant rule. Okay, next part. Now, zeros to the left side of a first non-zero digit are not significant. What is the meaning in that case? Always remember, if we have a zero before a non-zero, they are not significant. For example, I am writing a number which is 0404. I can say that this 0 which is present before a non-zero, it is not significant, but this 0 which is present between two non-zero is significant. So total number of significant figures in this case are actually 3 only. For example, I am saying we have 0.4. In this case, significant figure is only 1. This 0 has no meaning at all. Let's say we have 0.004. In this case, significant figures are again 1. Let's say we have a number which is 0.012304. In this case, significant figures are this 0, not significant. This 0 is present between two non-zero, significant. So 1, 2, 3, 4, 5. So we have total 5 significant figures. I hope this part is clear. Very simple rule, very simple rule. Next part, zeros to the right side of a first non-zero digit may or may not be significant. Now this is the most important part and the most confusing one. For example, I am writing a number which is 12400. If there is no decimal after non-zero, just remember significant figures are only 3. So all these zeros, if there is no decimal point after non-zero, they are not significant. We have a number 8000800. Significant figures are only 1, 2, 3 and 4. 4 significant figures. Okay. Now let's say I am saying we have 111.0. Now in this case, 0 is present after decimal, after non-zero and after decimal. Okay, now in this case, significant figures are actually 4. The most easiest way I am saying, I know this rule is quite confusing to most of the students. I am simply saying first of all, just observe the 0 which is on the right hand side. If there is no decimal, no point of discussing that particular part. If there is decimal, then you can count it. Okay. So let's say I have 500.0. Very interesting question. So this decimal is after non-zero, 5 is non-zero, and after decimal, so I have to make sure that this should be significant. This is significant, this is significant. So all the zeros between two significant numbers or two non-zero are significant. So I can say we have total significant figures which are 4 in this particular case. Very interesting scenario, very interesting scenario. Okay. Let's say I am writing a number which is a 0.0400. This question, this is the beauty of significant figures. Now you know that this decimal and zeros which are before non-zero, they are not significant, but these zeros are after non-zero and they are after decimal also. So I can say in this case, significant figures are actually 3. The most important question, okay. Now the last part which is exact numbers. So whenever I am counting, in that case, let's say I am counting 2 balls, I am counting 20 pencils, they are exact numbers. So always remember, exact numbers have an infinite number of significant figures. The main confusion in this case, how to identify that we are talking about the exact number. So it may be anything. It may be the velocity of light, some quantities. It can be your dozen. It can be your mole, 1 dozen, 1 mole. Okay. It can be your 1 dozen, 1 mole. It can be the counting part also. Counting of quantity. The question is saying that I'm counting 20 balls, I'm counting 20 apples. Let's say in the question itself it's giving as 20 apples, I'm counting 20 apples. So the exact quantity which is in counting gives us the exact number, and exact number can be having infinite number of significant figures. For example, let's say I'm talking about a dozen pair, like a dozen quantity. So it means I have a 12 let's say pencils. I have 12 pencils. Exact number, it can be 12.0 pencils, nothing new. It can be 12.00 pencils because it's not going to change anything. It can be 12.00, infinite number of 0 pencils, it's not going to change the meaning. So our exact number always have infinite number of significant figures. In that case, total number of significant figures are actually infinite. That's all. That's all. These are the rules which are related to the significant figures. I hope the entire part is clear. Okay, next part is, okay, this question is from JEE Main, very simple question. The edge of a cube is A, which is 1.2 centimeters, then its volume will be recorded as. Now we know that first of all, the volume is going to be A cube. Okay, so there are certain rules which are related to the calculation of significant figures. So there are certain mathematical operations. It can be addition, subtraction, first part. It can be multiplication as well as division, second part. So whenever you are dealing with the mathematical operation of addition as well as subtraction, you need to make sure that answer should be written in such a way that matches with the number having least decimal points. Okay, so this is the first part. And for multiplication and division, always remember answer should be written in such a way that it has exact number of significant figures present in least quantity. Okay, what is the meaning in this particular case? Let's say I'm multiplying two numbers. One is having two significant figures, one is having three significant figures. I can multiply that entire part, but I need to make sure that I am writing the answer in such a way that the answer should contain least number of significant digits. Okay, so these two parts are actually very important, and from that part, from these two parts, you can see there is a very simple analysis, which is the rounding off principle also arises. Okay, so definitely we are going to use the rounding off because we are converting higher significant digits into lower one. So for example, the A is already given in this particular question and we have to calculate the volume. We know that volume is A cube. It means in this case we have 1.2 whole cube, which is centimeter cube. Now you can see in the options, the question is very interesting because first part is dimensional analysis. We have to convert this centimeter cube into meter cube, and the next part is I need to make sure that this 1.2 is multiplied 3 times. Definitely I am going to get more significant digits, but I need to make sure that in multiplication I have to write the answer in such a way that I'll get least number of significant figures. So in the question, this 1.2 centimeter is having only 2 significant figures. So I need to make sure that final answer also has 2 significant figures. So if I'm multiplying this 1.2, the value will be 1.44 multiplied by 1.2. I guess. Okay, I guess it is, yeah. So I can say we have 4 multiplied by 12, 1.728. Okay, so that will be 1.728 centimeter cube. Okay, now I know that 1 meter cube is equal to 10 raised to the power 3 decimeter cube, which is equal to 10 raised to the power 3 liter, which is equal to 10 raised to the power 6 centimeter cube, which is equals to 10 raised to the power 6 ml. Okay, so I can say that 1 meter cube is equal to 10 raised to the power 6 centimeter cube. So 1 centimeter cube is 10 raised to the power minus 6 meter cube. So I can say that 1.728 multiplied by 10 raised to the power minus 6 meter cube. First part, it is already done. But in the final answer, you can see we have 1, 2, 3, 4, 4 significant digits. It means the answer is not correct. So I have to round off this particular part. This is more than 5. So I can add 1 in the preceding number. So that will be 1.73 multiplied by 10 raised to the power minus 6 meter cube. Again, the answer is having 3 significant figures. This number is less than 5. So I can make it as 1.7 multiplied by 10 raised to the power minus 6 meter cube. That will be my final answer. Very interesting question. So the final answer in this case will be option number C, 1.7 multiplied by 10 raised to the power minus 6 meter cube. You can look at the entire part and just let me know if you have any confusion. Okay, definitely we will discuss some other questions. Okay, next part. Next question says a student performs a titration with different burets and finds titry values as 25.2 ml, 25.25 ml, 25.0 ml. The number of significant figures in the average titry value. So if I talk about the first part, which is average titry value, it's very easy. So we have 3 values, 25.2 plus 25.25 plus 25.0 divided by 3. Either I can solve this entire part, or in first measurement the value is 25.2. Significant figures in this case are 3. Next part is 25.25. Significant figures in this case are 4. 25.0. significant figures in this case are again 3. So I know I have to make sure that answer should be having the value, final value, having only 1 decimal point, because the least decimal points are 1 only. Okay, and significant figures are going to be 3 in this case. So the final average titry value should have only 3 significant figures. So there is no need to solve the entire part. By simply looking at the measurement values, you can see that least number of significant figures are only 3. That means the final answer is going to be 3 only. Without even solving the question, you can simply talk about the answer. So the final answer in this case is going to be 3. So it talks about the number of significant figures in the average value, which is going to be 3. Okay. Now the next part is, okay, round up the following upon up to 3 significant figures. It's a very interesting question. So in this case, if I talk about the first part, okay, so in this case you can see 1, 2, 3, 4, 5. Total 5 significant figures are there. So initially we have 5 significant figures. So I need to remove this 6. It is more than 5. So I can add 1 in the preceding number. So it will become 34.22. Now in this case, you know, we have 4 significant figures. I need to make sure that I am converting the entire part into 3. So this number is less than 5. So there is no need to add 1 in the preceding number. So I can say the final answer will be 34.2 only. And you know, in this case, we have 3 significant figures. I hope this part is clear. This is the basic idea about the rounding off. Now in this question, you know 1, 2, 3, 4, 5, 6. Okay, we have 6 significant figures. First of all, if I am removing this, I need to make sure that I am adding 1. So that will become 10.411. Okay. In this case, you know, we have 5 significant figures. Again, I am removing this number. This is less than 5. No need to add. So we have 10.41. In this case, we have 4 significant figures. This one is again less than 5. No need to add anything. So 10.4. We have 3 significant figures in this final number. Next part, which is quite interesting. In this case, you know, we have 1, 2, 3, 4. 4 significant figures. Now, if I am adding, if I am removing this 6, I need to make sure I am adding 1 on the next side. So if I am adding 1 on the next side, it becomes a 10. So I need to make sure I am adding 1 on this side. So you can say the final answer becomes 0.460. Yeah, 0.0460. So with the help of only one single operation, you can say the final value is having 3 significant figures, because this 0 is going to be significant after decimal and after non-zero. Okay. Next part, again in this case, you have to remove this number because we have 4 significant figures. If you are removing this particular part, it becomes 1. So the final value will be 2810. If it becomes 2810, this 0 has no meaning. You have significant figures which are 3 in this particular case. Very interesting question from NCERT, and to give you a basic perspective about the rounding off as well as the idea of significant figures. Okay, now after completing the entire part, now we are coming back to the main concept about the chemical classification of matter. We are talking about the chemical classification, which has 2 components. First part is pure substance, next part is mixture. Pure substance is having only one type of species, and in that classification we know the first part is element, second part is compound. So let's try to decode the basic idea about the elements. So basically we can say that elements are basically the pure substances. They are the simplest form of pure substances. Which actually contains only one type of particles. This is the most important thing. They only contains one type of particles and have a definite physical and chemical properties. They can be metal, they can be non-metal, they can be metalloid. But let's say, for example, if I'm talking about a gold ring or a gold ornament, I can say all the atoms which are present in that gold ornament are actually made up of gold atom only. Let's say I'm talking about a piece of coal. I can say in that case all the atoms are only carbon atoms. So that is the basic idea about elements. And we have 3 categories. First one is the metal, which are malleable, which are ductile, which are sonorous, which are good conductor of heat and electricity, which are shiny in nature. These are the properties, basic properties of metal. Now in that case, we have different type of examples in the periodic table itself. Iron, cobalt, nickel, zinc, you can take sodium, potassium, magnesium, calcium, whatever the example, they are of metal. Okay. In the same way, the next part is all those elements which are not showing the properties like metals. They are not sonorous, they are not shiny, they are not malleable, they are not ductile, they are bad conductor of heat and electricity. Definitely those are non-metals. And examples are carbon, sulfur, chlorine, fluorine, bromine, neon, argon. All these are the examples of your non-metals. Metalloids, basically those elements which are having properties in between metals as well as non-metals, which show certain properties of metal and certain properties of non-metals. Those are actually known as metalloids, and in that case we have again different type of examples. Mainly we have silicon, arsenic, germanium, we have antimony. Now the task is for you guys, you just have to let me know the answer in comment box. Take any example of metalloid. Let's say take the example of silicon. Can you explain one property which is similar to metal and one property which is similar to non-metal, which shows the behavior of a metalloid? So just let me know the final answer in comment box, like one property or 2 properties, whatever you know, of a silicon or any of the metalloid which is similar to metal, and one property which is similar to your non-metal. Okay, just let me know the final answer. Okay, next part is basically the compounds. So in that case, I'm talking about the pure substance again. So in that case, they are also pure substances, but in this case, they contain more than one type of elements. Definitely in that case, they contain more than one type of elements and have different properties than that of constituent elements. For example, I am taking the example of H2O. H2O is comprises of two elements. First one is hydrogen, next one is oxygen. So H2O is having different properties, definitely different properties than hydrogen as well as oxygen. But you can see in that case, composition is actually pure, it is fixed. We have only H2O molecules in the entire water compound. Okay, but the elements are different. We have hydrogen as well as we have oxygen. You can take different type of examples. You can take let's say N2O, you can take NO, you can take CO2, you can take CO. These are the examples of certain compounds. Now, how can you classify? Definitely, we have two classifications. First one is actually known as inorganic compounds. First one is basically inorganic compounds. Basically, all those compounds which are originated or which are actually derived from earth crust. So these are the actual crude definitions. I'm not saying they are always true, but these are the crude definitions in case of inorganic compounds. So I can say first part is inorganic compounds. Next part in this case is definitely organic compounds. So the meaning of organic compound is very easy. They are supposed to be derived from the living beings. But we know like this definition is not true. We can synthesize the organic compounds, but the basic meaning of organic compounds nowadays is all those compounds which are derivative of hydrocarbons. Mainly compounds of hydrogen, carbon and any heteroatom. Okay, those compounds are basically your organic compounds. In that case, you know the example of ethanol, very well known compound from your 10th class, and propane, a simple hydrocarbon. So these are few examples of inorganic as well as organic compound. Inorganic compound, you know, NaCl, CaCl2, MgO, CaO, you have copper sulfate, CuSO4, iron sulfate, FeSO4, all those compounds which are basically derived from earth crust. Okay. I hope the entire part about these compounds is clear to everyone. These are the theoretical aspects. Trust me, this is the only and only lecture in which we are going to talk about the entire theory of this particular chapter. I hope you know all these things. If you are not aware of all the things, if you are not able to connect with the idea of measurement as well as significant figures, this lecture is going to be very helpful for you. And yeah, that's all, because most of the time when we deal with the problems of chemistry, like the same thing happened to me when I was in 11th class. When this particular chapter comes, my teacher was always saying like, this is the most important chapter, this is the most important chapter, you can find different applications in different chapters. Definitely that's true. You can find the application of this chapter in thermodynamics, in equilibrium, even in redox reactions, in atomic structure, in gaseous state, in solutions of 12th class, in electrochemistry of 12th class, chemical kinetics of 12th class. So definitely this chapter is very important. But why I'm dealing with significant figures, why I'm talking about the error analysis, why I'm talking about the dimensional analysis, why we are talking about the units, that part was like, I was unable to like correlate with that particular part. And I always try to give a basic perspective, like these things are actually very important. Whenever you are doing the experiment, you need to make sure that you know all the significant figures, you know the measurement is going to be accurate or precise, you know that these are the units I'm going to use for that particular experiment. And this lecture comprises of all those things. Okay, so if you have started watching this video now, just move back to the first portion where we were dealing with the basic analysis of the particular lecture. Okay, trust me, this is the foundation lecture, I can say, correlating all your concepts from 9th and 10th class, and giving you the idea about what is coming next in the next lecture, like the basic calculation of mole and all those things. Okay, now the next part is atoms and molecules. So again, if we talk about elements, if we talk about compounds, we need to make sure that we know the much more fundamental parts related to elements as well as compounds. So every type of element or compound is actually made up of atoms. So what is the meaning in that case? It is basically the smallest particle of an element, or you can say, if I am using a layman language, I can say compound also, which may or may not have independent existence. So what is the meaning? Generally, atoms do not have independent existence unless otherwise I am talking about inert gases. Okay. So one thing you should know about me, that I never use the term this is the exception, because whenever I say that this is the exception, you are going to like use the ratification process to mug up that particular part. Like sir is saying this is exception, I need to make sure that I remember this thing. There is nothing to remember about that exceptional part. Exception is a very simple thing. It's the deviation from the regular phenomena, nothing else. So he has an exceptional performance. It means like the performance is very far from the average performances. So that is the meaning of exception. So nothing new, nothing fancy, nothing like you have to remember this particular point. So I can say like inert gases are the exception of this independent existence. No. The meaning of independent existence is inert gases can show independent existence even in their atomic form, because inert gases are actually very stable. If something is stable, then it will try to remain stable as it is. So they don't need any compound formation, they do not need any molecule formation, because they are already very stable. And all the other elements and their atoms, they are not stable in their atomic state. So they need to make sure that they are bonding with other atoms to form a stable compound. Okay. So in that case, I can say the smallest particle which may or may not have the independent existence. Independent existence, if I am talking about only inert gases. For example, helium, neon, argon, krypton, xenon, radon, oganesson, all these are the examples of your inert gases. Rest of the atoms are not stable, so they don't have the tendency to exist independently. I hope this part is clear. Now the molecule, they are again the smallest particles, but they have the tendency to exist independently. Okay. So again, these are the smallest particles of an element or compound which can exist freely. So if I talk about element hydrogen, we know its molecule is H2. So when we are combining two hydrogen atoms, they have the tendency to exist independently. So which means they are forming a molecule. Molecules are more stable, definitely. Oxygen, it is O2. Solid phosphorus, it is P4. Sulfur, it is S8. Water, it is H2O. N2O, CO2, CO, all these are the examples of your molecules. I hope the entire part is clear. Now the next part which is relevant to your analysis is basically the representation of the elements. So basically representation is again a very interesting, very simple term. In the representation, you need to make sure that you know the symbol of that particular element, you know its atomic number, you know its mass number. I'm not talking about the atomic mass, you need to be very careful. I'm just talking about the mass number, which talks about the total number of neutrons and protons present in the nucleus. That's it. So first of all, elements are represented by their chemical symbol with the help of atomic number and mass number affixed above and below as indicated. So let's say this is the X, X is the symbol of the element, Z is basically the atomic number, which is equals to the number of protons, and in the neutral atom, if I'm talking about the neutral atom, this number is equal to the number of electrons also. A is basically the mass number, which is the summation of number of protons as well as number of neutrons. For example, I'm using helium. Helium is 2He4. 2 is the atomic number, He is the symbol, 4 is the mass number. That is the basic idea about the representation. So I have a simple homework for you guys. You just have to write down the actual representation of first 20 elements. Okay. So the first thing you should know in this case is basically your atomic number. The second thing which you should know is basically the mass number. So atomic number is basically the number of protons present in the nucleus of every atom, and always remember, in case of neutral species, in case of neutral species, this is Z value corresponds to total number of protons, which is equals to total number of electrons. Okay, first part. Second part is the mass number, which talks about the total number of neutrons and protons present in the nucleus. So I can say that number of neutrons can be easily calculated. Number of neutrons can be easily calculated, which is your mass number minus atomic number, because mass number is the summation of number of protons and neutrons and atomic number is number of protons. So you can calculate number of neutrons very easily. I hope this part is clear. Now the time for homework. I can simply say what you have to do. In the homework, you can try to write down representation of first 20 elements. Okay, just write down the representation of first 20 elements. Okay, that's it. That is your homework. Okay, now let's talk about a very simple question. So if the mass number of zinc is 65 and the number of electrons, protons and neutrons in zinc atom is, so first of all, the representation is Zn for zinc, and in this case its mass number is already given, which is 65. Its atomic number is actually 30. Okay, so the actual representation in this case is Zn 30 and 65. That is the representation of zinc. Okay, now it is a neutral species, so we know that Z will be equal to number of protons, which is equals to number of electrons, and this Z value is actually 30. So we know in this case we have 30 electrons, 30 protons. Now if I talk about the number of neutrons, that will be A minus Z, that is 65 minus 30, and that value will be equals to 35. So you can say number of electrons, they are 30, number of protons, they are again 30, and number of neutrons are basically 35. So the final answer will be 30, 30 and 35, which is option number D. I hope the entire part is clear to everyone. So that is the entire analysis about your basics of this particular chapter. We have discussed the entire portion. Okay, now the next part is atomic mass unit. Definitely I am not going to start the atomic mass unit. I am just going to give you a basic introduction part related to atomic mass unit. So whenever we talk about the mass analysis in the macroscopic scale, so a matter which you can easily see, like you can see a simple crystal of sugar, a simple crystal of salt. So that is the macroscopic quantity which can be seen by our naked eyes. Definitely in that case, when I am talking about the mass, we have the apparatus which is going to measure that particular mass. It can be gram, it can be kilogram, whatever it is. Now when we are moving from macroscopic to microscopic world, so this particular matter, which is the actual sugar or your salt, you can see the smallest part in that case is a crystal. Again, if I am talking about the dimension, it is in centimeter or meter, but this particular part is 10 raised to the power minus 9 meter, or I can say it is 1 nanometer, which is very, very small. You cannot see this crystal. So let's say I am talking about the measurement of this crystal, weight measurement of this crystal. You cannot weigh the weight of that particular crystal because it's a very small, very, very small. You cannot talk about the calculation of weight. Again, let's say I'm moving to further more microscopic world. I'm talking about the atom, or I'm talking about the atomic nucleus, which is very, very small. How can you weight that particular atom? Let's say I have one carbon atom. Let's say I have 10 hydrogen atoms. Can I weigh the amount of 10 hydrogen atoms on the weighing scale? Not possible. Not at all possible, because they are already very, very small. So in that case, I have to derive. I cannot use this gram or kilogram whenever I'm talking about the microscopic quantity. whenever I'm talking about the microscopic quantity, I cannot use this gram or kilogram. I have to derive another unit. So we know that for microscopic quantity, I can use a very simple term for the calculation, which is basically known as AMU. So this term was actually derived to actually calculate the mass of very small quantities, which is basically your AMU term, that is your atomic mass unit. So in the next lecture, lecture number 2, we are going to deal with all the calculations related to mass, calculation of mole, calculation of their atomic mass, calculation of their molecular mass, all those things we are going to discuss in the next class. I have certain questions for your homework, so you can solve those questions by yourself. Okay. This is your homework. You can see certain questions are into the conversion part of basic units, significant figures, largest numbers, all these things, the calculation related to significant figures. These are from your NCERT. So you can solve those questions by yourself, and in the next lecture we are going to discuss the next as well as the most interesting portion. I thought that I can discuss the calculation of mole in this lecture, but it's not that relevant. First of all, you have to absorb the entire information related to the basics of the accuracy, precision, significant figures, scientific notation, all those things. And I suggest you to just read the NCERT book itself. First 2-3 pages are very interesting, and after that you can find out all these things whatever I have discussed, like the basic idea about your scientific notation, significant figures, quantities, measurements, accuracy, precision, all these things you can read out by yourself. And if you find any difficulty, just let me know. Okay, so that's all from my side. I hope everyone enjoyed this session, learned something new from this session. Remaining part we will discuss in the lecture number 2. Okay, so that's all from my side. Thank you so much.